This is why I made a lab notebook. A lab notebook is technically a notebook that has like the notes and and other and other tips about that subject. What I did here, I did a pre I did a lab notebook about differences between geometric sequence and arithmetic sequence. If you don't know what's geometric sequence nor arithmetic sequence, I'm gonna explain. By the way, a sequence, a sequence is an arrangement of numbers in a particular pattern. So also, before we even continue, the there's going to be a word known as term. Terms are just technically the numbers that are used. So first we go to the geometric sequence. The geometric sequence, this is this is a sequence where all of the every term except the first one is being multiplied by the common ratio. Then the previous term needs to be multiplied by the common ratio to get to the next term. There are also two different types of formulas that you can do: explicit formula and recursive formula. The difference between them is that explicit formula, this is where you get things that are very far. If you try using geometric sequence in like a line, it goes 2 times 2, if the first one is 2, and then the common ratio is 2. You times both of them. So 2 times 2, 4. 4 times 4 times 2, 8. So on and so forth. So it becomes complicated if it goes to 20 spaces. So you don't, so that's where the explicit formula comes in. The explicit formula would help answer that problem by first using A1, which is the starting term, then timesing that by r, or the common ratio. Then you do n minus 1. That means the position. Like there is for A40, that is the position. 40, A40, the 40 part is the position or where it is. So once you do that and you minus by 1, you're able to get the previous term. Then you times it by A1 times r. Then you get your answer. Recursive formula, this is used, this is used to help find the to help find the term in front of it. If it's a big number, like you're times it by a specific amount, you can use this to also help by big number. If the common ratio is very big, you can use this, or you can even also use this to solve previous ones. But thing is that you need to get that previous an. You need to figure out that an muna. The an is the term and the location it's in. The examples of geometric sequence are self-dividing. As you might know, cells divide into two, then two of those cells divide into four, and then it gets more and more and more. Another one is that a ball bouncing, because once you jump it from a specific height, it decreases by a specific amount. Like if I jump a ball 1 feet, and for every it decreases every half a feet. So that's how it kind of works. Arithmetic sequence is kind of nearly the same as geometric sequence, but instead of multiplying, you add the terms to what is called the difference. Difference. You add the previous term to the difference to get to its next term. As the explicit formula would also work, would have the same use for the arithmetic sequence and also the recursive. They still have the same uses. Examples of arithmetic sequence are a clock ticking. For example, for every 1 minute is 60 seconds. So it clicks every 1 second. So you're adding it by 1. Then example, climbing up a ladder. You go one step, you go up by going on each one step of a ladder. So you're able, so you can really see where you can use arithmetic sequence and geometric sequence in your daily life. Do you have any questions?
Yeah. How parang it's kind of similar, no? Pero what are the differences? Ano lang, name one, okay lang. At
Okay,
least one.
geometric sequence, this, as I said before, you times it by the common ratio, and it would equal to a bigger number.
Mm.
But sometimes it can be times by a negative number. Arithmetic sequence, arithmetic sequence uses addition. Sorry, you add the previous term to the difference to get a number, and you can even use it to integers like -1, -2, plus you can the combinations can be that even.
Okay, so thank you. The operation that was used, no, on the geometric is multiplication, and here in arithmetic is um addition, no. And also parang yeah, the number is bigger usually in the geometric sequence, no.
Yes.
But it doesn't parang but the difference, I mean when it when it progress, it doesn't mean na equal or exact, how I would say, something like that, no. And then the arithmetic square, parang it's equal ba? Is that right?
Yeah, kind of like that.
Parang
But
it's more precise, parang would you would you say it like that?
yeah, yeah, but there's also another one, which is the Fibonacci sequence. Fibonacci
Mm-hmm.
sequence is another example that is a sequence where the first number is being added by if there's 1 and 1, that becomes 2. And if there's 1 and 2, it becomes 3. And all the time, it will resemble a spiral. You can find this in nature, like seashells, ferns, and even cyclones. It's actually pretty cool. But unfortunately, I
Yeah.
didn't include it. But here's the arithmetic, arithmetic and geometric sequence. This is my lab notebook.
Wow. So it's really interesting, no? See? Ano lang, math, pero when you put it and when you put some, like, you can picture it through yung cell division, no? I was able to understand it better, no? When you, when you give the example. So thank you.
When I first learned about geometric and arithmetic sequence, it really got my head spinning.
Yeah.
Once I was able to understand it, thanks to some simple notes, it became a lot more easier.
And it's really interesting pala, no?
Hmm.
Especially if you can associate it with, the things around you, like
Yeah.
how the clock works, no? Oo nga, it makes sense. And yung sa cell division, no? It multiplies talaga. So, yeah. Thank you.
Okay. So this is for my geometrics. This is for my pre-algebra project. This is where I made my own painting about the geometric sequence. You can already see that the first base here has 1. Then it splits into 2, then 4, 8, and 16. The common ratio that it's used is times 2. You times it by 2. So 1 times 2 is 2, 2 times 2, 4, 4 times 2, 8,
Wow.
16. I even had
That's
a,
a great illustration, no?
yep, got even here
If
16.
only we could understand math, no, using art, wow. That would be really interesting for the student or the learner.
It was very fun to do. I really had a blast.
Wow, that was very creative of you, ah.
Hmm.
Good job.
Here, this is for another pre-algebra project. This is known as rate and ratio. The difference between rate and ratio is that rate, you're comparing it to a different unit, like 1 gram, 1 gram of salt for every 1 liter of water, I think. Or example, $10 for every 20 sodas. While in ratio, you're comparing two two things that are in the same unit. Like for every 1 cup of water, you add 2 cups of flour to the mixture. So what we did here is that we grabbed 1 cup of mixed nuts, and then I separated them and weighed both of them. So what happened? It took a while for us to especially separate them, but at least some of them that have fallen into the ground, some that spilled, at least I'm able to eat some of those. So it's a win-win. So what we did here is that we also did a percentage of what each of these mixed nuts and chips are in it. And you can see that corn is the most with 33.6%. What happened? My mom even added some questions here that I had to solve, like what is the ratio between corn and peanuts? Then it's 42 and 38. I'm able to decrease that to 21 and 19, 21 to 19. Then here for green peas to corn, it's originally 33 and 42. Then I decreased that by 11 and 14. Then the question, one of the questions here is saying, which one has the highest proportion? And I said corn because it made up 33.6% of the entire mix. And mom added a new one, which is, if one jar is 300 grams, how much of corn will it most likely weigh? The mixed cup of nuts weighed around 1 125 grams. So what I did here, I did a very easy one for corn. So what I did here, I did 300 grams times 33.6%. I Then I got my answer. The corn in the jar weighs around 100.8 grams. 100.8 grams. Here, what I learned how to be patient because this really took a long time, believe me. And I also learned how to use proper math and ratios in day-to-day things. But I don't think it's like day-to-day thing if you're trying to mix nuts. But I know all, after experiment, none of the nuts got wasted. I ate them. So it was pretty good.
Yeah, you know what? It's always been on my mind whenever I eat mixed nuts. Which one kaya is has the most, number, di ba? Palagi I have that question, parang, in passing lang on my mind. Pero, I didn't do something about it, no? At least you were able to solve it, no? The corn has the greater number, no, over the green peas and the peanuts. So,
Yeah.
yeah.